Hi everyone, in today's lesson we'll be looking at arrays in C. So what are the lesson objectives of this lesson? By the end of this lesson we will learn how to define an array in C, how to declare and initialize an array. We'll see how we can access and manipulate array elements. We'll see how we can add, replace and delete elements in an array. We'll see how we can get the size of an array. We'll also look at how to handle array out of bound errors in arrays, work with one-dimensional and two-dimensional arrays. Then so we'll try to make it to be very practical, like I've always done all the videos. So what is an array? It's a collection of elements that are of the same data type, right? So and these elements are stored in a contiguous memory location, so and we can access them using a single variable. Now in every other thing that we've been doing, we have been declaring like int a equals to 5, integer b equals to 10. Now what if I have like 1,000 records that I want to store? It means I have to declare 1,000 variables. If I have like a million, imagine Facebook that have billions, over how many million users, right? Imagine the number of tweets that are being tweeted a day. So if Twitter want to, or X want to load all of that and declare variables for each user, so it will be like millions of users. So this is where array comes in, right? And arrays, they actually help us in storing multiple values in a single variable. So we have a single variable, as we can see. So I can declare an integer array like integer number, right? And I can now give the number of values that I want. I can declare the size. Let's say I want an array that takes 10,000 elements, right? And now I can do a declaration and initialization, which we're going to see, right? But I just want us to know that the importance of our arrays is that it helps us to store multiple values of the same type using a single variable, right? Like what I have done there. I want to store 10,000 numbers in this single variable num, right? You see this, if we were using but variables, right? If we're using variables like this, right, and it will be difficult for me to create 10,000 variables like int a, int b, int c, int b. So they are useful because it can help us, arrays can help us to handle larger data sets, right? It helps us to handle larger data set. I've also said that we store multiple values in a single data type, in a single variable. It helps us to optimize our code. Imagine writing 10,000 int statement to declare 10,000 variables, and this is what I've just done here with an array. So it optimizes our code. It helps us to make our code more manageable and reusable, right? They are the basic data structure. So array acts as the basic data structure. So now let's look at arrays from a graphical point of view. So now this is an array, right? So if I declare an array, this is how it will be stored in memory, like we said, in a contiguous memory. Now so this will be like the first element, right? Number 1, number 2, number 3, number 4 up till. So if I'm storing something like 10 here, right, I can store like 20 here, I can store like 30 here. Similarly, I can store a name here like John, right? I can store like John here inside. I can store like Snow, right? I can store like Peter, right? I can store like Mary, right? Continuously. Now array index starts from 0, so that will be like 0, 1, 2 and 3. Then it continues like that. So now when we want to access, for example, if I want to access 10, I'll access it using the index 0. If I want to access 20, I'll access it using the index 1. All right. Similarly, if I want to access Peter that I was writing here, I'll access it using the index 2. So we're going to look at that much practically. So all elements in an array must be of the same type. That is one thing that we must know. And also the size of an array, that is the number of elements, must be specified or be determined during initialization. For example, here I've specified the size to be 10,000. I can still do like this, right? So now this will be determined during initialization, like as I'm adding values. So I've created an empty array, and so or this, no, like this, for example, 1 2 3 4 5, right? So the size will be determined that, okay, this will be 5. So look at how we can get the size of an array. Okay, so all array elements, we access them using a square bracket. So if I was, let me just do, I've not included this stdio.h. I don't know how I missed that. Then int main, let me have return 0 here. Okay, so the syntax, as we've seen, to declare an array, this is it. So we have the data type, the array name, and the size of the array, and the value. So we can declare like this. Then we can do initialization, right? So we can do data type, array name, then the size, then the value. So this is, we're doing initialization already, right? So we can declare like in this first case, and then we can do the initialization like this. For example, this, I'll declare an array num, right, that takes 10,000 elements, and then here I've declared an array number, and I've initialized it with 5 values, integer values, right? So I can also do partial initialization, like int n, and I put there 5, and then do like, maybe I just have 3 6. Yes, so this is partial initialization. So here we've said we're doing initialization. And then we can also do partial initialization. We can do explicit, like this one that I've done here. Okay, let me put this one as explicit initialization, right? Because it's determined at let me do something like double salary, then the size is 3. Then I want to take the salary of 3 persons, let's say $500, 600, and 700. Okay, 700,000, 600,000, 500,000. Okay, so if it's also char, we can do char name, right? And I do John, right? I can do char hey, and I do something like this, H E, comma L, comma L again, comma O. Yeah, so all of these are just different ways in which we are initializing. So I have said, was I doing implicit? Yeah, sorry. Okay, so all of these I have initialized different arrays. Now we're saying, okay, accessing elements. Now all of these above, you should know how to initialize them, right? So accessing the elements, I'll just do print f of the first one there. I'm going to do %s percent f salary at index 1. We've said it starts from index 0, so let me do at index 1. So it prints that to double precision. So, and I can do this percent 1f. Let me see. No, wait. 0.1, 0.2f. Yes. So percent 0.1 or 0.2f to 1 decimal place or 2 decimal place. So if I want, I didn't put a point, right? Okay, so we have that. I can put 0 if I want to print the first element. All right, so I can do percent 1f index 0. I can continue to do the same thing. Let me print another one also. Let me do the percent C. Then I do name at index 0. Let's see what we have there. So it's going to store. So I didn't have a backslash n here, but this is John, right? And now if we're storing John, right, using the same procedure, J will be stored here, O will be stored here, H will be stored here, and N will be stored here, right? So at index 0 we're going to have J, index 1 we're going to have 0, index 2 we're going to have H, and index 3 we're going to have that. So if I do this, let me put backslash n percent d backslash n at index 0, we should have J, right, for John. So if I do the same thing, print f percent c backslash n, then I do hey at index 4, we should be expecting 0, 1, 2, 3, 4. We should be expecting to have an O. Yeah, perfect. So basically this is let me also do for number, print f percent d. Okay, let's do number, right? So I have number there as int and at position 2. So if we do that, then it's supposed to print us position 2. We have 0, 1, 2. It will print us 3. So basically this is how we access elements in our array. Now somebody can actually do it like this. You can do an integer x equals to number at index 3. Then now you do print f percent d backslash n, then x. Yeah, it's still valid, right? You can still do that. It works perfectly fine, right? Now now I just want us to go. So let's assume that okay, we want to add the numbers to an array, right? Let me first of all print this result so that we see what we have. Yep, so it prints 4. It's good. Now let's take this array here, num, right? So if I try to do print f percent d percent d backslash n, and I put the num at index 0, right? So here we're going to have an error, right? Because we're accessing an array that does not have any element, right? So okay, now there is always a trailing 0 that gets printed. Now let's understand what happens, right? Let's go to like num and put at index 3, right? So the array has no element, so we've declared an empty array. Now we can add elements to this array by doing, I can do num at index 0, I can put there 10. Num at index 1, I can put there 20. So let's try num at index 10 and put there 30. Okay, let's see what we have. Let me run this and see if we're going to have. Okay, so now, but how do we know that we have items added to the array? So let me just do printf percent %d \n num at index 1. So it prints me 20. Now let's go to, let's do the same thing, right? Let's do the same thing at put at index 2, right? Index 2 is 0, but now let's go to at index 10 because we added something at index 10, right? You see it's 13. Now that means that if we come to this, if we come here at index 0, we have stored 10. So if we're working with the num array, here we've stored 10, here we've stored 20, then we have skipped up till somewhere we have put there 30, where we have at index 9, at index 10, sorry, at index 10 we have put there 30. So that is how we add elements to an array. We can also replace elements in an array by simply going there and putting num at index 1. I want to put there fee 500, right? So now I'll print back. Before it was, so let me put there after replacing %t \n. Then I put there num1. Then I'll print the same thing here, but now I'll put before replacing num1, and then after replacing we'll see what num1 has become. Compile and run. So before replacing was 20, after replacing is 500. Okay, so basically that is how we access, that's how we add, that's how we now we replace elements. So let's try to print all elements in an array, right? To display all the elements, in an array, we're going to use the for loop. So I'm going to do like for int I is equals to 0 or I less than num. Okay, now we need to know the size of num, right? So let's not work with num. I want to work with number that we know here. So let's just take number 5, then I plus plus, then print f. Oh, am I right? Print f value is %d \n of number into I, right? So if we do that, it's going to print all the elements in I, in numbers, right? That was from 1 to 5. So that is how we do. We can do the same thing for any array that we have defined above, right? For any array that we have defined above, we have defined char hey. So I'm going to do the same thing. If I just change this to hey, right, then it should print me the elements in hey. Oh my god. Okay, so it's supposed to be %f %c, right? So you just print hello, right? Basically this is what we can do. That is how we can actually add new members in an array, and we can go as far as displaying all the records. We've looked at replacing the elements. Then now if we want to get the size of an array, now because here we might not always want to know the exact number in the array, so we can use size of. So we can use getting size of an array. So we use the function size of, right, to get the size of the array. So I'm going to put here integer n, which would be the size of my array. So the formula is to get a size of the array itself. So let's say size of number, right? Then we're going to divide now by size of one element, like the first element at the space occupied by one element in the array, so at the index. So if I just print out %d n, size of array, right. So it should give me integer n. What is that? Int n. Let me look at the log. Why is it saying conflicting n? Okay, so I already do n up. Okay, yeah, so I have n up. So let me just put z, right? Z. So n was already declared up. That's why we have that. So the size is 5, right? So I can go ahead and declare an array and get the size of the array, right? Basically as simple as that. We can do all of that. Now arrays, like I've said, they help us to store multiple values in a single data type. So we can create, we have one-dimensional arrays, two-dimensional arrays. So everything that we've been creating has been in 1D, right? Everything that we've been doing has been one-dimensional arrays. Now we're going to move forward to two-dimensional arrays. Two-dimensional arrays use it's used to store values like in the form of a table or in the form of a matrix, like something like this. So in a 2D array, this is what we're actually doing, right? So we're going to, like, in a tabular form like this, right? So this is like index 0, 1, 2. This is 0, 1, 2, right? So we'll be defining a matrix like this, for example, A, B, where this will be rows and these are columns. So these are columns and these are rows. So basically that is how a 2D dimension is defined. So using matrices, right? So I'm just going to come here and do 2D arrays, right? They're in form of tables, or let's say matrix, right? So I will just use the syntax. The syntax is to do data type, name of array, definitely. Then we have the rows in the columns, right? So for example, I can do integer matrix, which is going to be a 2 by 3 matrix. So the one that I defined there was a 3 by 3 matrix, and I can initialize its values, right? I can initialize the values like, okay, let me say I have this. Now I'm going to have the first one. I don't want it this big. Yes. So this will just be like 1, 2, 3, then comma 4 comma 5 comma 6. So this will be something like this. Two by three, 2 rows, 3 columns, like this. So 1, 2, 3, 4, 5, and 6. So this is index 0, 1, and 2, and this is 0, 1. So if I want to access 2, this will be 0, 1. So basically, if I want to print out the element of this, I can do %d, then matrix at index 0, 1. So this will print me a setting 2. I don't have any backslash n there, so you attach behind 5. Okay, so there's supposed to be backslash n here, and also I put backslash n here so that I don't have it prints me 2, right? So that is it. So basically this is one of the, these are some of the few things that we can do with arrays, right? Basically there's a lot of things that we want to do with arrays. Now I'm going to be, we've seen how we can look through an array, we've seen how we can declare an array, we've seen how we can do basically a lot of things with arrays. So arrays is actually the go-to place when you want to store multiple variables in a single data type. Like I've said, it acts as the basic building block for many data structures like queue, stack, and all that we can continue to mention. Now, if I want to print out all the elements in a 2D array, so this is what we're supposed to do. Print display all elements in a 2D array. Okay, so I'm going to use like a nested for loop, right? So the first for loop will go through the rows. So I'll do like integer I. Yes, integer I is equals to 0, I less than 3, I plus plus. I is not less, I is the row, so rows are actually 2 rows, so it's going to be I less than 2. Then the next for loop we have for integer j equals to 0, j less than 3, so this is supposed to be less than 2, j plus plus. Now this is going to loop through the columns, so I can do now a printf %d backslash n matrix of I and j. Yep. I can do printf here %n. I just do a backslash n here. So after printing, it goes to the next line. No, I know what I've done. There's no backslash n here. Yeah, that's correct. So if you see, this backslash n is actually pushing everyone back by one space behind. I'm supposed to give just a space there. So basically this is what we're going to have, which is cool. Now this brings us to this question, right? For those that are doing the HNZ, right? The HNZ, this is a typically this is which session? 2023 session of those that are writing the Cameroon HNZ exam, right? So basically this is a loop, and a loop which consider the following loop. We're going to discuss this, but now this is the point that I want to emphasize. Consider the following pseudocode. Declare a 2D array that takes 10 rows and 10 columns as integer. Declare arrow C as integer also. Then arrow starts from 1, which is the row starts from 1 and loop to 3. Then the column starts from 1 and goes up to 3. Then it says that if arrow is equals to C, then put 1, else put 2, 0, and then comes here, and then it just loop through and print just the same way that we have done the loop. If you look at the loop there and this loop here is basically the same thing. So now I'm going to explain how this will be done, right? So we have a 3 by 3 matrix like this. In this and this. So this is 0, oh sorry, 1, 2, 3, 1, 2, 3. So this is our arrow and this is our C, columns and rows. So it says that if C is equals to, if arrow is equals to C, then put 1. So here 1 is equals to 1, so it's going to print 1. So when arrow is 1, C is 1, then we put 1. When arrow is 1, C is 2, they are not equal, so we put 0. And then also 0. This definitely, arrow is 2, C is 1, so they are different, 0. Arrow is 2, C is 2, correct, 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 and 1. So this will be the output of this loop. Alright, this is basically going to be the output of the loop. So if we look at the questions there, it says that we should look at what is the output of code corresponding to the pseudocode 10 marks. So that is it that we've done above there. Implement the previous pseudocode in the language you master most. So I think we have already done part of it, and so I think what we're supposed to do is just go a little bit. Let's just do integer cure. We declare a 10 by 10 matrix, then int arrow C. So it starts by saying that for integer, for arrow equals to 1, arrow less than or equals to 3, arrow plus plus, for C equals to 1, C less than or equals to 3, C plus plus. Then we should do if arrow is double equals to C, then you're doing cure at arrow C is 1, else Q at arrow C is double equals to 0, right? So then after that, so this will create the array, the matrix, and then this is supposed to display. So I just remove all of this and I'll do a printf statement here, and I'll put %d space, just like the same printf question that we have down there, I j. Then here I'll do a printf %d, no, just \n. So basically the implementation, this loop is the same like the one that we did above. Sorry, so this is supposed to go to this one up here. Right. So this is the HNZ 2023 part that we just answered like that. This is a code that you're supposed to write. This is a code that you're supposed to write, and it's going to give us the perfect outcome. Okay, so let's run the program. We have percent the, oh sorry, here is arrow and C. Okay, so this is our matrix here. So this was a previous example that we did. Like there was a previous example that I did, but this is a matrix, just like I explained in the graphic interface that we design, right? Just like I explained, right? So it gives out the output as expected. Now we're going to continue with this. I just want us to do some exercise. So now the first exercise that we're going to do will be we're going to write a program that takes input 10 numbers from the user and find the sum. So we're going to declare an array that allows a user to enter 10 numbers, and then we find the sum of the 10 numbers, right? So let me just do, so it allows users to input 10 numbers and we find the sum. So in this exercise we're going to learn how to loop through an array and sum, and how to dynamically collect numbers from users. So I'm going to do a print statement here, printf, and put here solution to exercise. You can actually pause the video, go and do the exercise, then come back and look at the solution. Right, \n. So what I'm going to do here is I'm going to declare an array. I think I have an array called num_p, right? Because I've declared numbers above, an integer. So this will be, so we have declared an array to take 10 numbers. Now I'm going to do integer sum to be 0, so we'll start the sum with 0. Then I'm going to ask the user printf to enter 10 numbers. Now in order for me to achieve this, I want that each time that the person enters the number, we're going to store the number. So I'm going to declare, I'm going to use a for loop and do int I equals to 0, I less than or equals to let's just do strictly less than 10. Then I do I plus plus. So this will loop from 0 to 9, right? And they will fill the array space from 0 to 9. So I'm just going to do a scanf statement here that will take %d ampersand ampersand num_p. So this is where I want to be getting the numbers at position I, right? So it will be storing the numbers in that array. So each number that it gets, it will store in the array. Now what I can do is let me just go out here and let me print the sum. All right, so I'll just do another for loop. Let me print what is in my array, right? So I'll just do integer I equals to 0, I less than 10, I plus plus. Right, so I want us to, or basically I don't need to do, yes, let me just see, I don't need to do this, but I just want to, that we should see all the elements that we have added in the array %d. And so I just do num_p add I. So this will print me all the numbers. Let me put space here. So it prints me all the numbers. So I'll run the program. So it asks the person to enter 10 numbers. So I'll enter 10, 20, 30, 40, 50, 50, 60, 70, 80, 90. You see, so these are the numbers that I entered. You see, right? Now I supposed to make the sum, so I'll just come in here and do sum is equals to the whole value of sum plus num_p of I. Right. Then I can do a printf statement here. Put here the sum is %d \n. Then I put here sum. So the numbers that the person enters, we're just trying to sum them. Okay, so let me just put 1, 2, 5, 6, 7, 4, 3, 8, 1, 5. So the sum is 43, and these are the numbers that I actually entered, the 10 numbers. So I think this video is long enough, and there's a lot of things that we have learned in this video. If you find the video interesting, if you learn something in the video you like, you share, you invite a friend to watch, also share with a friend to watch, then you also subscribe. Thank you very much.